Good morning, everyone. This is Arnav speaking from PyCode. Today, we'll be looking at a new chapter from CBSE Computer Science Class 11, and that is Introduction to Problem Solving. Now, as you can see in the diagram shown here, there are various steps in problem solving. First, we have to identify the problem. Then we define what the problem is, explore the problem a bit, take some actions about it, and once again look back at the problem. Now, this takes place in a complete circle or a complete revolution. So, algorithms and flowcharts. So, intelligence is the key characteristic which differentiates a human being from other living creatures on Earth. And our basic intelligence allows us to do problem solving and strategies in daily basis, which arise day to day. The objective of this video is to be able to define a problem, define an algorithm, write algorithms for simple problems, tell the properties of an algorithm, what are flowcharts and the need for them, what symbols we use for flowcharts, and draw flowcharts for simple problems and convert flowcharts into algorithms and vice versa. So let's say a person goes to a bank to withdraw money. After knowing the balance in his account, he decides to withdraw the entire amount but has to leave minimal balance. Here, deciding about how much amount he or she may withdraw is one example of basic intelligence. During the process of solving any problem, one tries to find the necessary steps to be taken in a sequence. Now, this leads us to the definition of an algorithm. It is a sequence of activities to be processed for getting a desired output from a given input. Now, another definition could be a formula or set of steps for solving a particular problem. To be an algorithm, a set of rules must be unambiguous and have a clear stopping point. Now, there are five properties for an algorithm, and these were defined by Donald Irwin Knuth: finiteness, definiteness, input, output, and effectiveness. Finiteness is when an algorithm must always terminate after a finite number of steps. It means that after every step, one reaches closer to the solution. Definiteness is when every step of an algorithm is precisely defined. The actions are defined unambiguously for each activity in the algorithm. Any operation we perform with any value associated with it is called an input, and this value is given to the algorithm before it begins. Output is the result or the expected value or quantity in terms of the output of an algorithm. This may be obtained at different stages of the algorithm, and if the result is from intermediate stages, it is called an intermediate result. And if it is at the very end, it's an end result. Effectiveness is that the algorithms are developed using basic operations. Now, these operations should be basic so that they can be done exactly and in a finite amount of time by a person by using pen and paper only. So any algorithm should have all of these five properties, or they don't fulfill the objective of solving a problem in some given time. This use of algorithm has a given number of advantages. This helps in the development of the procedure itself, which involves identification, decision making, and variables necessary to solve the problem. This development also allows us and forces the examination of the solution in a rational manner. Identification of process reduces the task into a series of smaller steps. Problems that are difficult to solve otherwise can be approached as series of small solvable subproblems. Use of an algorithm also makes the process more efficient and consistent. Consistency comes from both use of the same process and increased skill in applying the process. An algorithm serves as a mnemonic device and helps ensure that the variables of the problem are not ignored. As time goes by and results are compared, the existence of a specified solution allows identification of weakness and errors. Reduction of a task to a specified set of steps or algorithms is an important part of analysis, control, and evaluation. One disadvantage of algorithms that I would like to talk today is that they always terminate. So there are computational procedures which are not algorithms, and all computational procedures, whether they terminate or not, can only give computable results. So this is one example of an algorithm where we are writing the steps for making Maggi noodles as a food. Now we start by taking the pan with water. We put pan on the burner, switch on the gas, put Maggi and the masala. Next, we give it 2 minutes to boil, take it out of the pan, take out the Maggi with the help of a fork or a spoon, and put the Maggi on a plate and serve it. Now we finally stop, which is the algorithm comes to an end. If you want to print good morning, the algorithm would be to start, then we print good morning and then stop. To find the area of a rectangle, we start by taking the length and the breadth and storing them as L and B as variables. Next, we multiply length and breadth or L and B and store it in area. Then we print this area which gives us the area of the triangle, and then we stop the program. To check whether a person is eligible to vote, he should be 18 or more years old. We write an algorithm for this by taking the age and storing it in the age. Then we check the age value. Now, if age is greater than or equal to, which is mentioned right here, 18, then we go to step 4, which is we print that the person is eligible to vote. Or we go to step 5, which is that we print that someone is not eligible to vote. Then we stop the program. To check whether a number is positive, negative, or 0, we start the program. We take any number and store it in n, or n being the number. Then we check the value of n. Now, if n is more than or greater than 0, then we go to step 5. Else, we go to step 4. Step 4 is checking the value of n. Now, if it is less than 0, then we go to step 6. Else, we go to step 7. In step 5, we print that the number is positive and we go directly to step 8, which is we stop the program. Else, we print the given number is negative and then stop the program, or we just print the given number is 0. Now, I will talk about flowcharts. Flowcharts are a diagram which visually represents the flow of data. This means by seeing a flowchart, anyone can know the operations performed and sequence of these operations in a system. Algorithms are nothing but sequence of steps for problem solving. So flowcharts are used actually for representing algorithms. Flowcharts show steps using boxes and we connect them with arrows. This gives us a solution model to the given problem. They help us in analyze, design, document, and managing programs in various fields. Now, so what are the building blocks of a flowchart or the common symbols which are used in a flowchart? Now, first is the arrowhead, which is basically shaped as an arrow, which points towards another, and it shows the flow or the order of operations taking place in a flowchart. They are added from left to right. Next is a terminal, which shows the beginning and end of the program. It is oval in shape or a rounded rectangle. It usually contains the word start or end inside this shape right here, called the terminal. Process is basically a rectangle which is used to show any operations, any changes in values, forms, or basically any change in data. So, like in the previous examples as we discussed, to take the product of the length and breadth, we store length into breadth inside, we put length into breadth inside this diagram, inside this rectangle called the process. The decision is a conditional operator. which tells us which path the program will take. And usually it's represented by the shape of a diamond, and the operation uses either a yes or a no or a true or false. So one decision could be yes and one could be false. And according to that, the program takes different paths. For input and outputs, we use parallelograms which show the input, the data which we're inputting and outputting, and also to display results. The advantages include communication, analysis, documentation, program maintenance, coding. It helps understand the logic of the system and shows us all steps of a solution. It can be used for effective analysis, and it helps in documentation purposes for knowing various components of the program and its complexity. It also helps in the maintenance and in the time to time management of it. Any design of the solution is converted to a computer program. So writing the code, referring the flowchart also becomes easier. There are a few limitations of using flowcharts. One is the complexity of logic. If the logic is complex, then flowchart becomes complicated. Any modification or alteration in the program logic may require redrawing of flowcharts completely. And we can't reuse the symbols, always reproduction of flowchart symbol. uh, because we can't type the flowchart symbols, I would like to correct myself. Reproduction of flowchart symbols is required. Now this is a simple flowchart to calculate the simple interest. Now first is the start and last one is the stop. So for any flowchart we always write the start first, which is more of an oval shape, and even the stop one first, which is an oval shape. Next, to take an input, we make a parallelogram and we input the values of P, R, and T, the principal amount, the rate, and the time period. Next, we make a decision. For that, we use a rectangle where we store the product of PRT upon 100 to the simple interest. Then we simply print the simple interest and stop the program. To find a bigger number among two numbers, we first start the program, and once again we check where the program stops. We input two numbers, A and B, and if A is greater than B, this is used for decision making, and this is a diamond shaped thing which is used for making decisions. If A is greater than B, so yes, then we print A is bigger. Else if it's no, then we print B is bigger, and in both cases we finally stop the program. And these arrows are used to go to show the flow of the flowchart. Now, try pausing the video and try for yourself to draw a flowchart to find factorial of any number. So, first we start the program. Then we input the number which we want to find the factorial of. Now, we store the value of I as 1 and factorial or f as 1. Now we check if I is less than equal to the number. Over here, I also represents the count. So if count is less than equal to number, then we print we store factorial is equal to factorial times count or I, and I is equal to I plus 1, or count is equal to count plus 1. Then we go back to the program and check if I is less than equal to n. If it is no, then we print the factorial and we stop the program. This helps us find the factorial of a given number. Try solving this problem on your own. To draw a flowchart to print the numbers from 1 to n. Another practice problem is to find the biggest number among n numbers. So to find the biggest number, we input the number, we input a, and we store the big number as a and I as 1. Now if I is less than equal to the number, then we once again input a, and if big is less than a, then big is equal to a and I is equal to I plus 1. But if big is greater than a, then it's no, and I is equal to I plus 1, then we go back to the program and check if I is less than equal to n. If it is no and I is actually greater than n, then we print the big number and stop. Thank you. That is all for today's session. And I hope you enjoyed the video and continue watching for more such content on Class 11 and Class 12 Computer Science CBSE. Thank you.